One thing I heard you say on a podcast, it's actually, I think, a really interesting point and potentially controversial point, is that optimizing for network performance is more important than optimizing for developer time. I don't think everyone across every ecosystem would necessarily agree with that. Some people are very, very, very pro developer adoption, and that's their North Star, right? Maybe we'll make some sacrifices on how performant our network is or our chain is, but we need to make sure we have developer adoption. Seems like you and the rest of the Solana ecosystem have taken a different approach, right? Some of the things we just discussed are fairly complicated, right? This isn't necessarily easy, right? So how do you see this? Do you still feel the same that you did when you first said that?
Coming from like the background in finance, we're almost like everyone in finance. It's like, hey, like the developer time is the thing that we can like manage, and we can manage the expenses in terms of like developer hours and how many like developers you need to hire to build something and like things like that. But it's much harder to manage complexity of the system and potential optimizations later. It's like this like black hole that nobody can estimate.
Hello and welcome to another episode of Devs Do Something. I'm your host, Sam Flamini, and this episode is going to be a first for the podcast. Today we're going to be looking beyond the EVM and doing a deep dive on the Solana ecosystem. Now we all know that crypto can be a tribal place, but we don't believe that technology has any reason to be tribal on its own. There are some very intelligent people who are doubling down on building in the Solana ecosystem, and our guest, Bartosz Lipinski, is one of them. Bartosz is the head of product engineering at Solana. I'll tell you more about his journey into crypto in the episode, but Bartosz is someone with deep expertise in building software for the world of finance. Before getting into crypto, he built trading systems for years at Citadel and worked as a senior engineer at JP Morgan. You can consider this episode as a crash course on building on Solana for engineers who have a deep familiarity with the EVM. We walk through the Solana execution environment, how token programs work on Solana, and some of the different mental models you'll need to wrap your mind around to build Solana programs. We also walk through how Bartosz thinks about building developer communities and what he's excited about in the Solana ecosystem. Whether or not you plan to build on Solana, Bartosz is an excellent engineer and something that we can definitely all learn from. So sit back, relax, and I hope you enjoy. Are you a DAO or crypto native business with salaried employees? Or do you perhaps work for one? If so, whether you're a team of 5 or 500, your organization can save time and money by streaming salaries with Superfluid, who also happens to be the beloved producer of this podcast. With salary streaming, your management team no longer has to worry about executing multi-sig operations every month or manually executing hundreds of separate transactions to pay their team. Contributors and employees, on the other hand, get paid by the second, which, to be honest with you, is a pretty killer benefit on the receiving end. Those of us getting paid via stream can connect our wallet to the Superfluid dashboard and see our balances ticking up in real time. It's kind of mesmerizing and feels like you're being jacked 10 years in the future. When you're paid in a stream, it flows in perpetuity until your team needs to adjust compensation, which effectively puts Web3 payroll on autopilot. Salary streaming is easy to set up thanks to our recent integration with CoinShift, the leading crypto treasury management platform. In just a few clicks, you can securely set up payroll for hundreds of employees in just a single transaction, all from CoinShift's dashboard. If this sounds like something you're interested in exploring, you should visit superfluid.finance/payroll and book a salary streaming demo today. Thanks to all of our sponsors. Let's get on to the episode. So we are here today with Bartosz from Solana. Welcome.
Hey, thanks for having me.
Yes, it's great to have you here. Today we're going to go fairly deep into an introduction to Solana for people that might be listening that are familiar with other environments. But before we do that, I'd love to understand just kind of like your backstory a bit and how you got into crypto.
Yeah, sure. So I worked for more than 10 years in traditional finance. Different investment banks. And then before crypto, Citadel is this trading firm in Chicago. And I was building trading systems. And I was leaving Citadel to go work for jump trading. But I had this thing like non-compete for like multiple months, almost a year, and I couldn't do anything like really with like technology mostly, especially in finance. And normally everyone will be like, "Oh, this is great. You can go travel and everything." But like as I actually started it, like COVID immediately started. So I was like stuck at home with like no job and just kids doing homeschooling. um, and I started just thinking, okay, what would fit into the something that I could work on the side. It wasn't necessarily for the money. It was just to keep myself busy outside of like reading COVID articles, how many people died. And I started going heavily into DeFi. And at one point, I chatted with Anatoly through a common friend from Solana Labs, and it seemed like the way how Solana was built was fairly similar to how you build trading systems in finance, and that looked very interesting to me. And before that, I did like some simple things in Solidity for like a few months, and that I compared to like writing JavaScript on Node. um, which is perfectly fine. It's like there's plenty of good applications built on Node.js, and it's just slightly different to what you would do at trading set. And they started building some DeFi protocols on Solana. And after a few months, I was like, this is kind of fun. And I told Jump that I won't be going there anymore. And that was kind of the story. It's like really boring story, no conviction.
Well, okay. So one thing that is interesting, though, and this is something that maybe from the outside in seems like fairly common within the Solana ecosystem, is that a lot of people that come from like a maybe traditional finance that have built like software in traditional finance or are familiar with software in traditional finance, something about what Solana is working on tends to click a bit easier than some of the other environments. Why is that the case? And correct me if I'm wrong if that's a mistaken assumption, but it seems to be true for you.
Yeah, like so when I started, it was like the ecosystem was just growing. So since I was in Chicago, still am, I started obviously talking with like friends in finance and like, hey, maybe you should like look at that. So hopefully some of that came from talking basically with people that worked at the market making firms and trading firms and them being interested in building. But fundamentally, I think it comes from the fact that Solana storage and processing is fairly similar to like Unix operating system. I like to compare it to a file system, and that I think enables people to realize that the processing in parallel like can increase quite a bit even from the point where it is right now. Like you look at it and it's like, hey, like going from 3K like on the mainnet, like 50K in like TPS in like controlled environment to like 1 million that you could see at breakpoint with Fire Dancer. Like people saw that actually like 2 years ago when they like, yeah, that like it kind of makes sense. Like there's the model allows you to optimize heavily, even if it is not right now. And I think that was the main reason why people like, oh, it makes sense.
Got you. So some of the mental models seem like they were fairly similar to what people were used to, and it was easier for them to kind of grok. One question I have for you. So we were talking off air that a lot of our listenership will probably skew towards people that are familiar with Ethereum and the EVM. And I'm curious as to like, we'll dig into some of the deeper stuff like the Solana account model and some other specifics. What high level mental models? I think I saw you say on a podcast you actually started off messing around with Solidity and you kind of dipped a toe into the Ethereum ecosystem, so you're knowledgeable about it. But from a high level point of view, what mental models for someone who has experience building smart contracts on Ethereum, like what kinds of things will feel very different for them when they start writing programs on Solana?
Yeah, so I think starting off like and I built very simple programs in Solidity. By no means like I consider myself proficient in it. Most of the smart contracts on Solidity that interact with users end up having at the very top of the contract this map of addresses to some state. And those are like the holders of tokens or like LP tokens or whatever, like a DeFi. And that mental model is very simple, similar to, again, Node.js. Like you're writing a single threaded script, you put some variables in memory when that script runs, and you have access to them. You have access to that whole state. And you don't need to worry from, again, comparison to Node.js, like how that state will be locked or not locked. Most of the time it won't because JavaScript is single-threaded and Node.js is single-threaded when it's accessing the memory. But it's kind of similar with Solidity. Migrating just that single line from your smart contract to a program on Solana can cause certain challenges. Because amount of storage that you have available to a single block of space is like 10 megabytes. That's like maximum that you can allocate. Most of the time, it's actually 10 kilobytes. And it ends up being stored in something that's called account. It's a very confusing term because accounts in blockchain are just used so frequently. And Solana, just like the basic building block is account. But it's really similar to file descriptor, again, in Unix operating system. So you have this file that you can access by the public key, and you can store some data in it. But it's not infinite. It will cost money, similar to Ethereum, but it will have limit. So then you're like, okay, I actually want to store like, let's say, 100,000 users. And you will realize, okay, like 10 kilobytes of data is actually not enough. So how do I go about it? And like, does that disconnect creates problems for people? Because you need to start thinking at the low level. It's like, okay, how do I split my data into some form of structure that spreads it across multiple files? And those files can be locked independently of each other when it's being executed. Where like Solidity engineer would focus more on the actual logic of the contract versus the storage of the data. Like the storage, at least for me, when I built basic Solidity smart contracts, like the storage was never a concern.
Yeah, I mean, it's a concern, I suppose, in terms of costs for all of the gas optimizers. I guess the Solana ecosystem maybe has to worry a bit less about that because I don't think gas fees are as much of a
No, you 100% need to worry about it, right? Like at certain level, the cost is prohibitive for certain actions, but it's like from the very beginning you need to worry about it, and that's I think the main difference. Like you can whip up quickly Solidity smart contract and don't worry about optimization and it will work. Where here you are forced immediately. It's like it will just not fit. You need to do something about it.
Interesting. Yeah, that is definitely not something Solidity devs think about, right? Like the hello world in Solidity is like an ERC20 contract, right? The standard token. And like the first thing in there is a mapping.
Yep.
So from like, address to it's a UN 256, which is their balance, right? And that just will scale basically. The feeling is that it scales basically infinitely to as many users who will hold this token as possible. But what you're saying is that in Solana, you have to start thinking about the fact that, whoa, this isn't just going to so easily scale. You have to separate out this storage amongst multiple files into some other structures. So maybe a really good way to go about like explaining this might be to just walk through like what is the ERC20 token equivalent on Solana, and like how is that laid out?
Yeah, sure. So the main difference, again, like this, like fairly big difference on Solidity, the ERC20's interface, and you just implement a bunch of methods, transfer, from, balance, things like that, and you have your own token, and you end up usually copy pasting some code with a map that maintains the balances. On Solana, by default, you actually don't need to do that. The token implementation is an instance. So the program that creates tokens is immutable and allows you to create two types of objects, something that's called a mint and the token account. And mint defines things about the token that are not changeable, and like describe all the tokens of that type. So it's end up being an instance of an object of a mint. And it has like things like decimals, supply, and who can mint the tokens, and who can like burn them and freeze them. And you create that file, and you don't even need to build like any smart contract or program on Solana to deploy your own token. You can do all of that with JavaScript, and you don't end up deploying a new code, really.
Okay, I see. So this is like a pre-deployed instance then that someone in the Solana community or that works at Solana Labs created. And then if I want to create a token, I just interact with this thing that it's already there that's immutable instead.
But it shows major difference, right? Where for most of the programs, they become this like utilities that you use to create other things. So again, analogy in Unix operating system is you would have grep, and you could pipe it to another thing, and it would interact with each other. So the programs become smaller, but you don't end up re-implementing it from scratch to maintain that interface. The interface stays fairly simple. It's always an account. You pass accounts around. And that way you can chain multiple programs together. Which again, the mental model is very different. So like coming from Solidity to Rust, like that people think about like, oh, Rust will be this like hard language that I need to learn because it's for operating systems and has like multi-threading and this. In reality, is like building programs or smart contracts in Solana, you'll probably use like maybe 30%, maybe 50% of the features of Rust language. And that will not be the hard like learning a new language, if you're an engineer, is usually not the hard thing. The hard thing is understanding like the execution environment and like what that execution environment gives you. And like Solana is just different from what you would get in Solid. Like I would imagine you could build programs on Ethereum in Rust, and they still would be very different from programs in Solana. Like the language is not what's important.
Yeah, that makes sense. So what you're saying though about you mentioned this concept of like a program is deployed and it almost becomes a utility, right? It's just there. You interact with it. You don't need to do anything new. So it creates an environment where there's it's basically code reuse, right? Except you're not reusing it. You're just interacting with this thing that already exists, right? Like, with Solidity, you have Open Zeppelin, right? You got to import Open Zeppelin every time. A lot of times you end up with these really complicated like inheritance trees. You have a bunch of imports and you're inheriting from a bunch of other contracts. And you have to, it is a bit of a pain to sometimes sift through that, and it can be difficult to understand what's going on. Is there like an analog for like inheritance within Solana programs? Like how does that tend to work?
So you can import code from other programs, just like any library that you can in Rust. But most of the time you do it to invoke that existing program rather to bring the logic into your code. So that end up reducing the cost of deployment new programs because this other thing is running. And like for a lot of things, it's end up being really fundamentally a difference between do you prefer interfaces versus implementations. And that argument really in computer science is like really old, probably traced back to like 70s. And some people prefer interfaces, some people prefer implementations. And I think you can make the argument for both. The argument that we were originally making for the token program is that it will increase Lindy effect and people will trust it more. When you, as a user, outside of being a developer, when I use new token on that written in Solidity, what happens is you don't know how the transfer method is implemented. You don't know how balance off is implemented, and sometimes it's a good thing, sometimes it's a bad thing. On Solana, you do know.
Mm-hmm. Yeah, that makes sense. I mean, it really is only deployed once, and people are just interacting with this pre-deployed thing. One thing you mentioned a bit earlier is this concept of like I want to maybe drill down a little bit more into this concept of like the separation of compute and state.
Yep.
What does that mean, and what are some of the implications of that for developers on Solana?
Yeah, so like your program by itself doesn't store any data. Um, so what that means, the data is always need to come from the outside, and that's supplied by the user. And it's a pretty good thing because again, then this code is really reusable, and it's like this like thing that you can really well test in isolation because you really just test input and outputs, and it behaves as a pure function, because it doesn't have any side effects. But the problem with it is you need to know all the things that you want to bring into the program. So again, going back to the ERC20, maybe if you're invoking something that requires knowing all the tokens that were released or all the holders of that token, it might not be possible to bring it into the execution because there are limits in terms of like how many accounts can be passed into the execution. So then certain things are just much harder to implement and you need to think about them differently.
Yeah, that makes sense. Yeah, I think does some of this is the fact that Rust is like the programming language is does Rust help with some of this? Because Rust, I think, allows you to be kind of granular in managing memory, and it is a kind of a beloved language.
Not really. I mean, I like you could build exactly the same model in JavaScript if you wanted to, or any language for that matter. As a matter of fact, like what happens really is Rust code compiles to something that's called BPF. It's this Barclay packet filter that you have in like Unix operating systems. So that's like a little VM, and the bytecode that's used by it. And it's compatible with LLVM compilers. So you can bring, C++ or like you can bring WASM if you wanted to, and execute it inside of Solana because it's just compiled to a different target. So the language doesn't like some things are harder, and maybe like some people are making arguments. Hey, if we had like Move, and some people are working on Move, then maybe there would be a bit of less boilerplate that you need to write because the language would take care of some of the things, but it won't take care of the mental model. And maybe another good comparison between the mental model is like NoSQL database versus SQL database. You could imagine like MongoDB, I can store everything in like a massive single object. And with like a SQL database, I need to split it into the tables and think about it. And like Solana, like account model is also very similar to like a SQL diagram that you can create. Actually, when we are discussing you creating a new program, one of the things that happens very early on is we create a data diagram that looks very similar to database diagram. Like those are the fields. This is how they interact with each other. This is the cardinality, which again, I don't think it's something that you would maybe start with in Solidity, but maybe I'm wrong.
Yeah, you're very right, and that's actually quite a good analogy, I think, between the SQL and NoSQL databases. Now, I think part of this is that it requires you to think through this stuff more upfront, right? Think about how this is going to be used much more upfront, because you will be limited by what you decide to do upfront, obviously. And it's the same. It's the same in Solidity, but it seems like it's a bit more restrictive in programs on Solana, which can be a good thing, right? When you're dealing in these kinds of adversarial environments on blockchains.
But it can be very annoying. So one thing that obviously starts with this is because all your data now comes from the outside, like literally accounts and everything, you cannot trust any of it. So you have more validation to do. So in Solidity, it's kind of similar. Like some inputs are specified by the user, but some state is controlled by the contract that cannot be changed by the user. You can trust that state, like internal state, assuming you validated, all the methods that have side effects. But in here, you need to validate like ownership of the accounts and like were they changed properly or not. So it's more validation.
Gotcha. Got you. And one thing I heard you say on a separate podcast you did is that, I don't know if it was a workshop or podcast, but you mentioned that upgrading contracts or programs, same thing on Solana is it's an easier thing to do than in other environments. Did I hear that correctly?
Yes.
And why is that?
Because that feature is directly built into the blockchain.
Interesting.
So if you open an Explorer, you actually can see immediately on the contract that there is an upgrade authority on that contract. And that can be either a multi-sig or a single account or an MPC, whatever you want to do. It can be another contract that controls the updates as well. But by default, when you deploy new code, you can say, hey, I actually want to retain the ability to upgrade that code in the future without bringing, complicated like proxy patterns that I think are one of the like bigger worries in terms of risk normally.
There have been issues with proxies for sure. Now, when it comes to this, so you mentioned there's a choice you make. Like, can I choose to make a piece of code immutable when I deploy it in Solana? Okay, so I have a choice to make it upgradable or just take the key and throw it into Lake Michigan.
Yep.
Choice. Okay. Interesting. Another question that I had is, and we've kind of danced on this a couple of times, but it sounds like the account model is pretty different with Solana. Can you walk us through the account model? I think there's like, I'll let you explain it, but
sure.
I'll ask a follow-up question from there.
So again, the accounts are files. And some files can be created directly by the user. And this is basically an account that has a private key that user controls, can have up to 10 megabytes, and has some public key associated with it. And you can just upload the data there as long as you sign the transaction that uploads the data to that account. Slight variation of the account is when the account is created by the smart contract. Then the maximum size is 10 kilobytes. And the public key that's displayed doesn't have a private key, but it's created based on hash function that the contract controls. So you can, the way to think of Solana and accessing the contracts is actually one giant hash map. So going back to the original problem, like if I'm building ERC20 and I want to move that map that I have in my Solidity to Solana, what I can actually do is hash the user's accounts with the token address or token mint, and that creates me a predictable account that I can access. And it's this dedicated storage that my smart contract controls, and only it can update. That user can store additional information about like maybe a balance of a token, so effectively that you win. And that's something that's called program-derived addresses. So this program creates this hash that's derived from the user effectively. And that's how you effectively port the hash map or the dictionary from Solidity to hash map on Solana.
And I saw there's something else called a data account. Did I read that correctly, or is that a thing?
So like all the accounts store data.
Okay, so, I see.
Or can store data. Like there's like this concept of a native account that stores balance of a sol. But that it's almost equivalent to like any other account. Like you can store the data there too. It's just a question how you allocate it.
So the thing to remember here is that accounts are files. The way to think about accounts overall is that it's just a giant hash map.
Yep.
Gotcha.
And don't get confused by things that are called accounts and owners. Like this, like one of the hardest things in computer science, and I always say that, is like naming. And we name multiple things accounts and multiple things owners. So we end up sometimes with like two owners and like two accounts. And you're like, okay, which account is what? That's why sometimes like I prefer this token account versus like a normal account. It can be annoying.
Yeah. Okay. Makes sense. So watch out for some naming confusion or collisions there when you're looking at Solana. Okay, let's zoom out a bit, and I want to talk through like some of the stuff you've personally maybe worked on and and your takes on like how different ecosystems are evolving in the space. One thing I heard you say on a podcast, it's actually, I think, a really interesting point and potentially controversial point, is that optimizing for network performance is more important than optimizing for developer time, right?
Yep.
I don't think everyone across every ecosystem would necessarily agree with that. Some people are very, very, very pro developer adoption, and that's their North Star. So it's like everything we can do to minimize friction for developers is what we have to do, right? Maybe we'll make some sacrifices on how performant our network is or our chain is, but we need to make sure we have developer adoption. It seems like you and the rest of the Solana ecosystem have taken a different approach, right? Some of the things we just discussed are fairly complicated, right? This isn't necessarily easy, but you are going to probably get some speed and performance improvements if you're able to deploy contracts on Solana, right? So how do you see this? Do you still feel the same that you did when you first said that?
I think so. Like that's again coming from like the background in finance. We're almost like everyone in finance. It's like, hey, like the developer time is the thing that we can like manage, and we can manage the expenses in terms of like developer hours and how many like developers you need to hire to build something and like things like that. But it's much harder to manage complexity of the system and potential optimizations later. It's like this like black hole that nobody can estimate. And like from the growing like blockchain and ecosystem perspective, maybe another point is usually you will end up with small group of people building important things that need to be very performant, right? Let's take like Uniswap, right? Like the most popular contract on Ethereum, like the team probably spent a lot of time like optimizing things, and the developer adoption there was not a concern. At least when I think about it, like building any complex system will take more time than to learn something that like forces you into optimization path. So I kind of feel the same. I think like ultimately building programs and software on the blockchain will be complex, and saving on like how easy it is to build like Hello World, and optimizing for that, and maybe optimizing like, oh, it takes someone a day to pick up this versus 2 weeks, increases challenges at the end.
Yeah. I think there's also, you made a very good point there about Uniswap. And I think what you're saying there is that there's kind of a power law at play here, where a very, very, very small number of developers might build the handful of applications that are used most on your chain. So, if that's the case, you might as well optimize for the performance of the environment itself, as opposed to just trying to optimize how many average or below average developers can build on what you're creating. I think that makes sense. How about developer experience in general when it comes to like L1 blockchains or base layers? It seems like, I'm not sure what your exact role is with, like, I think you're with Solana Labs, like the Solana Labs team, right?
Yes, I'm a head of product engineering at Solana Labs.
Nice. Yeah. I mean, so I don't know how involved you are with like developer experience stuff. I would assume, to some extent, but how do you think about it?
Yeah. So I think the developer experience has been improving, I guess, on Solana. One thing again that we kind of like, and this is why we picked Rust, is picking general programming language will actually reduce the time to like build on the blockchain. So instead of like building this like super simple language, or a language that's like easy to learn, we're like, let's pick something that's really general, and that has been proven really computer science and like software engineering for a long time. Like people don't like learning new languages, and if they can take the language that they know potentially from somewhere else and use the same tools to build on a different platform, they will do that. So when you are building on Solana, you use all the same editors that you would use for anything else. I use Visual Studio Code. There's a lot of people that use Vim. You end up using Rust and like compilers for Rust. There's nothing specific about the blockchain. And you install one specific CLI, that's Solana CLI. and that's pretty much it. So from that perspective, it's fairly straightforward. Like you can set up your machine probably like less than 10 minutes, like just copying like really 2 or 3 commands and like be up and running. Yeah, and then deployment and building, it will take some time to build or like learn Rust and like understand it will not be like a day. So you could probably deploy like a very simple hello world or like very simple program in a day. In my experience, like if someone knows how to build already some software outside of blockchain, it will take them probably a week or 2 to learn how to build on Solana and be like efficient.
Nice. So you can take advantage of all the Rust tooling and all the developers that know Rust and love Rust.
Yep. So what we are sometimes like we are doing 2 things to improve the developer, I guess, engagement experience. For the past year, we have been hosting these hacker houses around the world. We did like 27 of them. Those are like 1 week long events in different cities that are focused on learning and building new things. So the venue is not like a conference. Usually the venue for a week has like monitors, keyboards, and you sit and build. And that has been working pretty well. And then the other one is bootcamps. So we do like a couple of bootcamps a year where it's like 2-week onboarding experience into Solana. I'm organizing another one in January in Chicago. So from January 10th to 20th, you will be able to sit with us in our office and learn from people that build programs on Solana or work for Solana Labs how to build different protocols, and that will span from tokens, NFTs, DAOs, DeFi.
Nice. So lots of developer community things going on. How about you personally? Do you have any? This is something we like to ask people. This is far more general, right? So that you can answer with anything here. But do you have any favorite design patterns or projects you've worked on that you're particularly proud of that you like to call out?
So on Solana, like specifically, so that's like what I really like in terms of a pattern is composability through reusability. So you can take the existing program and add on top of it without changing the code. And this is how we build NFTs standard on Solana, where the token program was not changed. It still used the same fungible tokens, and non-fungible tokens are going through the same code. But we did an additional program that enriches it with like the metadata. And that pattern is like very powerful that I really like. It would be cool to have interfaces on Solana, more well-defined. So that's something that I understand is kind of missing, but
On that note, is there any tooling you wish somebody would build for the Solana ecosystem? Any requests for communities?
I think like the Etherscan is like much better Explorer, like in general. Like the explorers across blockchains are kind of like not that great, but like Solana are just like okay, but they're kind of hard to read. So probably say explorers.
Block explorers. There you go.
But that's very engineering view, right? Like because that's like the tool that they kind of like end up using the most with like introspecting everything.
What are you excited about that you've seen kind of bubbling around in the community to either get deployed or be built on Solana in the next 12 months or so?
Yeah. So one of the things that internally Solana Labs have been working on that for a while is like new version of the token program that I'm fairly excited. That has something that we are calling confidential payments. And what that means is basically we are using like at the token level, zero knowledge proofs for like transfers and making the transfers confidential and enabling that for any token on Solana without knowledge or zero knowledge proof. So that I'm kind of excited about.
That's really cool. Now this is going to be specifically built into the token program itself.
Yep.
Nice.
But like one thing to talk about the token program is anyone technically can fork it and deploy their new one. So there's nothing stopping you from that. It's just the interfaces for things on the top that are building are not very well defined.
That'd be huge though for a lot of use cases, business to business payments, payroll. Yeah, that's very interesting.
yeah, I'm very excited about it. And the code is all open source. So all the code that Solana Labs is building is in the open source in the Solana Labs repositories.
What are you using on the ZKP side?
Um, I can send it. Like, so you want to go to the Solana program library, and this is mostly like a custom implementation. So you want to go to program program 2022. Do we support links, I guess, here?
Yeah, I'll put a link in the show notes to it if you send it over. But I'll make sure I point people to that because it does sound very interesting as a use case.
Again, from the perspective that the developer, like when we think about the token program, it's harder to build something by the initial program, but then people deploying new tokens that support confidential payments will require no Rust coding and no Solana knowledge, which I think is something like very powerful out of the box.
Yeah. Yeah, I'm with you. No, that makes a lot of sense. I think that is a very, very good standard, and it's something that I think other ecosystems will probably take note of as well, because I think that's pretty important. You don't have to necessarily build an entirely different layer 2 or a separate side chain to support that. You can just do it directly on Solana. That's pretty cool. Okay. This has been a fascinating discussion. The last question I'd like to ask you, and the question again we like to ask most people who come on, is another very broad one. You spent a lot of time in traditional finance. You've done great work so far at Solana, but I would love to understand like what your overall hope is for blockchain and crypto and Web3 as an industry throughout the next 5, 10, 15 years. Like what's your long-term vision of what you hope this industry is able to accomplish?
Sort of like deliver all that's promised, like just more users. I think everyone is like really excited, and it's like what's like why I'm passionate is like looking at everyone is trying to innovate, and everyone is like super excited about it, but I don't think we ever like really see like large growth of the users, right? Like nobody has like 100 million users and like a billion, and like getting there I think will be tricky in terms of like education and making sure like people understand why it matters. So I really hope we get there. I guess that's like, because it's like I don't know if we can, like, people are saying, hey, this works, we raised a lot of money, but like if you were to forget about the blockchain and like everything from the startup perspective, one can argue the product market fit for most of those things has not been found yet. Like it's like, hey, like you have like your first million users, that's like congratulations. In traditional startups, some people would not probably even fund you.
It's very true. Yeah, I'm with you there. I think we have a long way to go, but at least right now, while things are kind of messy at the market level, it seems like people are building. You guys are building. A lot of people we talk to are building. So I hope you guys continue the great work.
Oh yeah, I'm super passionate. Don't get me wrong. Like super like excited about what's coming and like the people building. It's just I think we need to focus on like the actual growth of the users and how we get there.
Yep, with you 100%. Well, listen, is there anything else you'd like to make sure we touch on today, or anywhere you'd like to specifically point our listeners?
Again, bootcamp. I posted it on my Twitter profile. It's also available on like solana.com/events. Feel free to register either for the one in Chicago or the hacker houses that we are doing. The next one next year is in Istanbul in February. So super excited about that. And thanks for having me again.
Nice. Anyway, what's your Twitter handle for the people?
It's pretty long.
I will post a link to it in the show notes as well.
All right. Awesome.
Oh, hey, thank you so much again for coming on.
Yeah. Cheers.